Using notes for finding zero function, then we'll take a step back to factoring into sum or difference of cubes. We have rational root theorem, which means we're going to find the possible zeros for a polynomial function. So our p is the factors of the constant of 0. And our e sub n is your leading coefficient. Which is the coefficient of the degree. So we're going to list all possible rational zeros using the rational zero theorem, then list possible number of real roots and box roots. So in 1, our degree is 4. Degree 4 means 4 zeros. So in our chart, real and imaginary, real zeros can be 4, 2, or 0, because imaginaries come in pairs. So if degree 4 means 4 zeros and we have 4 zeros, we have 0 imaginary. If we have 2 real, we have 2 imaginary. If 0 real, we have 4 imaginary, because real and imaginary add up to 4. So let's find the possible rational zeros. P over Q. P are the factors of 4. 1 and 4 multiply to 4, but also 2 times 2 multiplies to 4. So factors are 1, 2, and 4. 2 is factors of 1, which is just. So to get our possible rational zeros, we're going to be dividing the factors by factors of q. 1 divided by 1 is 1. 2 divided by 1 is 2. 4 divided by 1 is 4. So this is the list of possible rational zeros, and this is determining how many real and imaginary solutions there may be. Next up, degree 3. That means degree 3. That means 3 zeros. That means our reals can be either 3 or 1. So imaginaries would be 0 or 2. Because real and imaginary must add up to number of zeros, or the degree. Then we start finding the possible rational zeros by completing the process of P over Q. P being factors of 9. So plus minus 1, plus 3, plus minus 9. Factors of the leading coefficient would be 1. So possible rational zeros be plus minus 1, plus minus 3, plus minus 9. Using the rational root theorem to find possible zeros as previous examples. We will then use trial and error to see which ones will give us the remainder for synthetic division. We're going to repeat the process until we have a degree 2, meaning a quadratic remaining quotient. When it is degree 2, we can factor to find the other zeros, or we'll use quadratic formula. Start with example 3. 8, 1. So P over Q. P is factors of 8. 1, 2, 4, and 8. Of course, with all positive, negative, and factors of 1. If we divide each numerator by denominator, we obtain possible rational zeros of 1. 2 divided by 1 is 2. 4 divided by 1 is 4. 8 divided by 1 is 8. And now we're going to use the rational zeros and the real versus the imaginary chart to determine what zeros will be. If we have degree 4, then we have zeros. When we can have 4, 2, or no real solutions versus imaginary 0, 2, or 4. Keep in mind that imaginary zeros come in pairs. So let's try in trial and error to obtain which value on this list is an actual zero. We'll start with trying negative 1. Write the coefficients from left: 1, negative 6, 7, 6, negative 8. Complete the process of synthetic division. 1 times negative 1, negative 1. Sum of negative 7. Negative 7 times negative 1 is 7. Sum of 14 times negative 1, negative 14. 6 plus negative 14 is negative 8. 8 times negative 1 is 8. Our remainder is 0. Great. That means that negative is one of the zeros. Now in the directions, it tells us to find the real zeros of the function, but there could be some imaginary zeros. And we'll see. Right now our focus is on real zeros. So let's continue the process. So, zeros are supposed to be 4 of them. We already found one of them, negative 1. Now we'll go ahead and find another one that works. By trial and error, we know that one works. 1, negative 7, 14, negative 8. Notice we're using resulting polynomial instead of the one given. We know negative 1 times, or negative 7 plus 1 is negative 6. Negative times 1 is negative 6. 8. 8 times 1 is 8. Negative 8 is 0. That means 1 is an additional 0. Now that we can process twice, we started with the 4th power, then we get to the 3rd power, now we're at the 2nd power. So because we're at the 2nd power, we can then factor the remaining power, x squared minus 6x plus 8, 0. Recall factoring, x times x is x squared. Now we need a of 8 and the sum of negative 6. Factor pairs that are possible are 1 and 8, 2 and 4. Which one is going to give us negative 6? 2 and 4. So negative 2 and 4 multiply to 8 and combine to negative 6. Set each one equal to 0. X equals 2. And minus 4 equals 0. X equals 4. So all zeros are negative 1, 1, 0. There were 4 zeros. Found 4 zeros. This example is now complete. Okay, negative 4. We have degree 3. That means 3 zeros. Real versus imaginary. Real is 3 or 1. And 0 imaginary or 2 imaginaries. Because the total of real and imaginaries is degree 3. Or 3. Possible P over Q. Factors of 18, 1, 2, 3, 6, 9, 8. All of which have a plus minus over factors of the leading coefficient of 1. So if we divide, we get the possible to be 1, positive negative 1, positive negative 2, positive negative 3, positive negative 6, positive negative 9, positive negative 18. That's a long list of possible rational zeros to try. So hopefully you get one that works. And I always try to start with 1 or negative 1. Let's try 1. Coefficients are 1, negative 4, negative 15, and 18. Bring the 1 down. 1 times 1 is 1. Negative 1, negative 3. Negative 3 times 1 is negative 3. Negative 15, negative 3 is negative 18. Negative 18 times 1 is negative 18. Okay? Now, that means 1 is one of the zeros. We started with degree 3. Now we're down to degree 2. Lucky for us, we can complete the rest by factoring. And if you're not sure on factoring, you can use the quadratic formula. You need a product of negative 18, so 1 and 18, 3 and 6, 2 and 9. But we need a sum or difference of negative 3. The only one that gives us a difference of 3 is 3 and 6. 3 minus 6 is negative 3. So we have positive 3 and negative 6. Set each factor equal to 0. So let's equal negative 3 after subtracting 3 on both sides. And x equals positive 6, adding 6 to both sides. So all of the zeros, we needed 3 of them, remember? We needed zeros based on degree 3. Are 1, negative 3, and degree 3, 3 zeros. We found all of them. That question is now done. What is the work on finding the difference in the sum of cubes? So notice the pattern here. When we're finding the difference A minus B. A is the cube root of a to the third. Cube root of 8 is 2. Cube root of x to the third is x. Cube root of 1 is 1. So a is 2 and b is 1. So we start filling in 2x for a and squaring it. Opposite of minus is plus. Times b. 2x times 1 plus b squared. B is 1. 1 squared. So simplify to 2x minus 1 times 2x squared is 4 squared. 2x times 1 is 2x. 1 squared. 1. Now we work with a plus. Plus, and then we're going to do cube root. So a is going to be 4x plus, and b is going to be cube root of 27, which is 3. And then we're going to do 4x squared. The plus is minus, so minus, and a times b, 4x times, and then b squared. B is 3. So simplify to 3x or 4x plus 3. 4 squared, 16x squared. 4 times 3 is 12. 12x. 3 squared is 9. This concludes the notes for finding the zeros of polynomial finding the zeros of a polynomial and finding the sum or difference of cubes.